Hey everyone, and welcome. Today, we're diving headfirst into the fascinating and sometimes terrifying world of algorithms. These lines of code, often shrouded in mystery, are increasingly shaping our world, from the ads we see to the loan applications we get approved for. But with great power comes, well, you know the rest. Today, we'll explore three major ethical dilemmas that arise from our growing reliance on algorithmic decision-making. We'll tackle the very human problem of bias, even in our seemingly objective algorithms, and delve into the often opaque world of black box algorithms, where even the creators can struggle to explain their decisions. So, buckle up, because things are about to get complicated, thought-provoking, and maybe even a little bit existentially terrifying. But hey, that's the world of algorithms for you. Let's get started. Imagine this, you're applying for a loan. In the past, a bank officer, likely a human being with all their inherent biases and flaws, would have reviewed your application and made a decision. Today it's increasingly likely that an algorithm is calling the shots. And on the surface that might seem like a good thing. Algorithms, after all, are designed to be impartial, consistent, and data-driven. They don't get tired, they don't have bad days, and they don't let emotions cloud their judgment. In theory, they should make fairer, more objective decisions than any human could. But here's the catch: algorithms are created by humans. And humans, as we all know, are inherently biased creatures. This means that even with the best of intentions, our biases can creep into the algorithms we create. It's like baking a cake. If you use a recipe with bad ingredients, the cake will taste terrible, no matter how good of a baker you are. Similarly, if an algorithm is trained on biased data, it will inevitably produce biased results. Take, for example, facial recognition software. There have been numerous cases where these systems, trained primarily on images of white faces, have struggled to accurately identify people of color. This isn't a malicious intent on the part of the algorithm itself, but rather a consequence of being fed incomplete or skewed data. So, while the idea of an emotionless, purely logical decision-maker might sound appealing, it's crucial to remember that even algorithms are products of our imperfect world. And as we'll see in the next chapter, the problem of bias in artificial intelligence runs deep. We like to think of algorithms as objective, like mathematical equations that always produce the same result. But the truth is, algorithms can inherit our biases in some pretty sneaky ways. One way is through the very humans who design and train them. Imagine a team of programmers building an algorithm for a hiring platform. Unconsciously, they might favor certain keywords or skills that reflect their own backgrounds and experiences. Perhaps they prioritize candidates from elite universities or those with specific hobbies listed on their profiles. These subtle biases, even if unintentional, can creep into the algorithm's code, influencing its decisions and potentially perpetuating existing inequalities. But it's not just about the conscious or unconscious biases of the creators. The data itself, the fuel that powers these algorithms, can be riddled with historical prejudices and societal inequalities. Let's say we're training an algorithm to predict recidivism rates, the likelihood of someone reoffending after being released from prison. If we feed this algorithm historical data that reflects existing racial biases in the criminal justice system, guess what? The algorithm will learn those biases and likely predict higher recidivism rates for certain racial groups, even if those individuals pose no greater risk than others. This is a classic example of garbage in, garbage out. If the data used to train an algorithm is flawed or biased, the algorithm's output will reflect those flaws. It's like trying to learn a new language from a textbook full of grammatical errors and regional slang. You might think you're fluent, but you're actually perpetuating inaccuracies. The challenge, then, is to recognize and address these biases, both in the algorithms themselves and in the data we use to train them. And that requires a critical eye, a willingness to confront uncomfortable truths, and a commitment to building fairer, more equitable systems. Alright, let's talk about black box algorithms. Now, this isn't some sci-fi concept, though it certainly sounds like it. These are algorithms so complex, their decision-making processes are opaque, even to the engineers who created them. Imagine you apply for a loan and an algorithm rejects you. You ask why, but the bank says, "Sorry, the algorithm decided, and we don't fully understand how it works." Frustrating, right? This lack of transparency is a major ethical concern with black box algorithms. When decisions that impact people's lives are made by systems we don't understand, it raises serious questions about accountability, fairness, and the potential for discrimination. Think about it. If you were denied a job opportunity, wouldn't you want to know why? Wouldn't you want the chance to address any potential misunderstandings or biases that might have influenced the decision? But with black box algorithms, that kind of transparency is often missing. And it's not just about individual fairness. In regulated industries like healthcare and finance, understanding how algorithms make decisions is crucial for ensuring compliance and preventing potential harm. If an algorithm used to diagnose diseases malfunctions or exhibits bias, we need to be able to identify the problem and rectify it. But if we don't understand how the algorithm works, how can we possibly fix it? The lack of transparency in black box algorithms isn't always malicious. Sometimes it's simply a consequence of their complexity. But regardless of the reason, it's an issue we need to address. Demanding explainability from algorithms, especially those that make high-stakes decisions, is crucial for building trust and ensuring ethical AI development. So, there you have it, the hidden challenges of our increasingly algorithmic world. From inheriting our biases to operating in opaque ways, these powerful tools come with a responsibility to understand their limitations and mitigate their potential harms. As we continue to integrate algorithms into every aspect of our lives, from healthcare to transportation to criminal justice, it's crucial to be aware of these dilemmas. We can't simply accept these systems as neutral arbiters of truth. We need to question how they work, demand transparency, and hold them accountable for their decisions. Thanks for joining me on this journey into the complex world of algorithms, because in an algorithmic age, knowledge is power. And together we can shape a future where technology serves humanity, not the other way around.